So good afternoon to the session. So today's my session is on the basics in the fluid mechanics. So I have discussed on the classification of fluids. So first topic is the classification. So first one is the ideal fluid. So uh, generally the fluid can be classified into five types. The first one is ideal fluid, a real fluid, and Newtonian fluid, non-Newtonian fluid, then ideal plastic fluid. So there is the no, they may have some few variation in the types classifications. The first classification being classified on the fluid which is incompressible and now no viscosity. So when say the fluid is an ideal fluid, it does not have any incompressible. The fluid is incompressible and have no viscosity. So such a fluid is called as ideal fluid. When we say the real fluid, which we can use in the real practice one, so that's say called as real fluid, it possesses viscosity. So example, we can take water, air. So this all comes under the category of real fluid. Then third one, Newtonian fluid. Here, the relationship will be drawn between the shear strain and the velocity gradients. Based on this relationship, we call classified into the Newtonian fluid and non-Newtonian fluid. When we say this Newtonian fluid is defined as shear stress is directly proportional to the rate of shear strain or velocity gradient. So then it's called as Newtonian fluid. So example, we can take the both the cases. We can take the real fluid as example of water, and Newtonian fluid we can take water as the example. So next one is non-Newtonian fluid. So here we know that non-Newtonian fluid. So this is the curve stress strain relationship which determines the following: ideal solid, ideal plastic, non-Newtonian, Newtonian, and ideal fluid. So these are the stress strain relationship we can explain about the fluid types. So our next type is based on the non-Newtonian fluid. Here, the shear stress is not directly proportional to the velocity gradient. Okay. So here it's known as non-Newtonian fluid. Example: plaster, slurries, and paste. So these categories all comes under the non-Newtonian fluid. So ideal fluid can yield some value. If the shear strain is more than the yield value, and shear strain is proportional to the rate of shear strain or velocity gradient, is known as ideal plastic fluid. So these are the five types of fluid. Then we comes into the category of classification of fluid flows. So the first fluid flow is laminar flow and turbulent flow. Okay. So the general classification is laminar and turbulent flow. Here we say the laminar flows are travel in a well-defined path. It means that it travel in a very smooth way here. So this type of flow is called as a laminar flow. So in picture we can see this the laminar flow, the difference between the laminar and the turbulent flow. So this laminar flow, the water will flow like only without any deviation and does not have any high velocity. It have low velocity while compared with the turbulent flow. In between that, we have this transitional flow. So here the transitional flow means when the flow is converted from the laminar to turbulent. So in between that, we have this transitional flow. So we can see this layer by layer that there is no changes in this velocity, but here there may have some changes in the velocity. But in a turbulent flow, it will be a zigzag way, a way which is formed due to the high velocity in a zigzag way. So this the way flow is called as turbulent flow. Okay. So this is the difference between laminar flow and turbulent flow. So this is the thing I have been explained in the previous slide itself. Then we have to move into the next type of the fluid, that is natural fluid versus forced fluid. So natural fluid is which is flowing through the gravity. It does not need any external source of energy to move from one portion to another transportation. But in a forced fluid, there is some pump or fan has been used to transportation of water from the one pot to another pot. So this is called as a natural flow, and then next thing is the forced flow. Then steady versus unsteady flow. So how it means that steady and unsteady. So this also comes under the classification. Here, the steady flows, which means that there is no changes with the time and at any point of the flow. Where the water can flow, we cannot provide any time changes. We cannot see any time changes during the traveling, during the movement of water. So it will be opposite for the unsteady. Here, it can changes each time based on the location or over the specific region. So this is called as unsteady flow. So the both the things has been totally entirely different. This was the opposite to the next one. Next, we have the properties. So that's all about the classification of flows. Next, we have the properties of fluids. So we have few properties. That's general properties of the fluids, or every fluid have its own density. Even water have the different density, and oil have the different density. Then mercury have different density. Then another honey have another density. So density is differ based on the fluids. Okay. So that's properties also comes under the densities comes under the properties of fluid, surface tension, capillarity, fold, rise, then specific weight, specific gravity. So this all categories comes under the properties of the fluid. So here the properties are similar, so familiar that pressure, temperature, volume, and mass. So these are the most commonly used properties. So then other than that, we have few properties. That properties has been elaborately, so I can explain in the slide. The first thing is density. So density, which means that density, how we calculate the density, it means that mass of the fluid to its volume. Okay. So the numerator will be the mass of the fluid divided by that's denominator will come into the volume. So this is the calculation for finding the density. So density having the unit of kg per meter cube. So especially we know that the specific gravity for the mercury is 13,600 kg per meter cube, as it's a standard one, and water having the specific gravity of 981. So there is a 981 kg per meter cube. So we are not used that the 981. So instead that we have used the 1000 as a round off value for kg per meter cube. Okay. So these are all the properties, general things about the properties. So here we have discussed. Next slide, move to the properties. I have said that density or mass density. So it's a mass of the fluid divided by volume of the fluid. The volume of density of water is 1 kilogram per centimeter cube or 1000 kg per meter cube. So this is the unit for finding the density. So next one is specific weight. So specific weight, which means that specific weight or weight density of the fluid is the ratio between the weight of the fluid to its volume. So the generally we have to mention that weight to its volume. So it is denoted by the symbol of W. So it can be written as W equal to rho into G. So how the calculation has been made means W equal to weight of the fluid divided by volume of the fluid. So weight of the fluid, which means that mass of the fluid, weight we can say it as mass into the acceleration divided by volume of the fluid. So here we convert this into a W equal to rho into G. So this is the specific weight. Then specific volume has to be taken. So specific volume, which means that volume of fluid divided by mass of the fluid. Okay. So the specific volume of fluid is defined as the volume of fluid occupied by unit mass, or volume per unit mass of the fluid is called a specific volume. So mathematically, it can be exposed as volume of the fluid by mass of the fluid. So it having the unit of meter cube per kg. So it's commonly the specific volumes applied to the gases. So next one is specific gravity. So already we seen in the previous slide about the density of the uh, fluid or liquid. So the same thing, we know that this dense specific gravity has been clearly give that weight density of the liquid by weight density of the standard fluid. So this is the exact one for the specific gravity, weight density of the liquid, that is the unknown liquid we have been taken in a numerator, and known liquid have been used in a denominator. So it's been a dimension less one. So it has been indicated by using the symbol of is. So specific gravity have no dimension. We have not used any unit for this specific gravity. So specific gravity for each and every liquid has get differed by its own. Okay, so this is the in specific gravity. So the specific gravity of different fluid has been given in a tabular column. So water having the specific gravity of 1, so that is 981, which is directly we can take it as a 1 specific gravity. Water, I already know that the substance which is at a 0 degree Celsius, we can consider this values. While it is beyond the 0 degree Celsius, we cannot say the same specific gravity will be attained. So based on the deviation in the temperature, the specific gravity will get differ. So these are the few examples for the has been given in a tabular columns of example as a specific gravity. So these are the one type of the specific gravity. Okay, so here is the simple problems which can explain the specific gravity, the specific weight and density of a liquid. So by with this problem, I can conclude this the properties of the fluid. So volume is the problem which is given as calculate the specific weight, density, specific gravity of 1 liter of a liquid which is having the weight of 7 Newton. So Hoshin has been given that 1 liter of the liquid which are having the weight of 7 Newton. So they ask us to find out the specific weight, density, and specific gravity. So those three has been find out by using this formula. So previous slide we have discussed with the formulas for the based on these properties. On this behalf of these properties, we know the formula for specific weight, that is weight by volume. The density, that is rho by volume. So rho means density by volume, mass by volume. Then specific gravity is nothing but density of water divided by density of so density of liquid, that is unknown one divided by known one, that is density of liquid by density of water. So this is the formula that we have seen in the properties itself. So while we are using this formula, we can find out the value for the specific weight, density, specific gravity. So now we use one by one. So first thing they ask in the question to find out the specific gravity. So for specific gravity, it has been using the symbol of W. So W having the formula of weight divided by volume. So already the weight has been given in a question as 7 Newton. Then volume, which is nothing but 1/1000. So by using this, we can get the specific weight as 7,000 Newton per meter cube. So next thing, density is W by G. So weight is 7,000 divided by 981. So in the previous step, we have find out the W's value. So directly we install this W and get the density as 713 kg per meter cube when its weight is 7 Newton. Then specific gravity having the formula density of liquid by density of water. So density of liquid, that is the unknown liquid, that is 7135. Then we know the standard fluid density, that is 1000. So while calculating this, we get the specific gravity as 0.7135. So we arrive all the data what has been asked in the question. So that's all about the properties of the fluid. Okay, thank you for the wonderful session.